Question 66 gives me a set of inequalities, and it asks me to graph that system of inequalities and to shade its solution. As we've been discussing this chapter, each one of these equations represents a constraint, and essentially they're eliminating possibilities. And all those possibilities that remain after looking at 2, and we've looked at, I think, up to 5 or 6 restraints, that region that's still allowed is your solution region. So let's go ahead and look at both of these. I'm going to begin by setting up an xy Cartesian coordinate plane. So we have here both our x-axis and our y-axis. And you can see that one of the grid units is equal to 1 unit. So this is just 1 to 1. Let's graph the first inequality. That first inequality has a y-intercept of -7. So I'm going to move down a bit here. And at -1, 2, 3, 4, 5, 6, 7, I'm going to place a dot. And that's the y-intercept for that line. And from there, I'm going to move the slope pattern. It says is a rise of 2 and a run of 3. So I'm going to go up 2 and then over 3. Let me zoom in a little bit here. Sorry about that. Up 2 over 3, and then up 2 over 3, and then finally up 2 and over 3. So I have a pretty good idea of what's going on with that. This particular constraint, this equation was greater than or equal to, so I'd use a solid line there. Let me put my ruler down and go ahead and trace that. So this will be a solid line. And trying to make it go through those points pretty well. That's okay. And this is y's are greater than that. So in fact, if I was to plug in the point 0, 0, that inequality becomes 0. If I plug in this point 0, 0, x is 0, y is 0, that says that 0 is greater than or equal to -7, which is true. So it is a solid line, and we're going to be shading above this, right? For 2 reasons, right? It's y is greater than this curve. The other thing is I tested the one point at the origin. Our next curve has a y-intercept at +4. Let me zoom in a little bit. And it has a slope of -1. So from here, we're going to go down 1 over 1, down 1 to the right 1, down 1 to the right 1, etc. And this particular boundary line is not solid. It's dashed because it says that y's are less than the curve. So it's going to be a dashed line, and its value is below this line. And also we could test the point 0, 0. 0, if y is 0 and x is 0, that would say 0 is less than 4, which is true. So we're going to be shaded above this line, this constraint, and it is this constraint is a dashed line. So ruler down, and once the ruler's down, I'm just going to draw the dashed lines here. All right, and I think I'm supposed to shade the solution region, right? Yeah, shade its solution. So in order to do that, let me grab a highlighter, and I'll get a beautiful yellow highlighter. That's an ugly yellow highlighter. Let me get a purple highlighter. That's nice. Okay, and then I'm just going to shade the solution region. So anything that is above the 1 curve, including lines on it, and everything that is strictly below this other curve, right? This is a dashed line, so we're not including any of those values. Everything that I'm shading in purple, all these xy points, represent values in which both inequalities would be satisfied. And we can see there's a lot of them. All right, that's it for question 66.